Hello everyone, this is Pankaj and I welcome you all to new day, new question series. So once again I have brought you one more question for you. Let's see what we have in this question. So as we can see, the question is saying we have 1 kg of water which is at the 20 degrees Celsius is heated in an electric kettle whose heating element has a mean resistance of 20 ohm. RMS voltage of the mains they have given 200 volt. Ignoring the heat loss from the kettle, time taken for water to evaporate fully, they are asking. Here specific heat of water they have given as well as the latent heat of water also they have given. So let's try to understand what is the meaning of this question. So basically in this question what they are saying, we have one kettle and in this kettle we are boiling the water. So how much time it will take for completely like evaporating the water. So the key concept is here the heat supplied by kettle. Key concept will be heat supplied by electric kettle will be useful for evaporation of water. So for the evaporation of water we will need the heat. So we can write it in this way also. Basically we will write heat required for the evaporation of water. Heat required for evaporation of water. This is the key concept which we are going to use here. Now let's write the given data. So we have basically mass 1 kg, temperature 20 degrees Celsius. So mass of water they have given 1 kilogram, temperature of water initial 20 degrees Celsius. After that resistance of the coil of kettle which is 20 ohm, voltage is basically your 200 volt. Specific heat of water they have given one more thing which is 4200 joule per kg degree Celsius, as well as latent heat of evaporation of water they have given which is 2260 kilojoule it is. So we will have to multiply by 1000. Now it will be joule per kg. This is the given data they have given. And what are they asking? They are asking us to find the time. Okay, so let's write this as equation number 1. Let's put the value in the equation number 1. So heat supplied by the kettle will be in the form of basically power into time. Electric power formula we have basically V square by R. So from equation 1 it is V square by R into T. Now for the evaporation heat required for the evaporation of water will be, first we will have to take that water from 20 degrees Celsius to 100 degrees Celsius, and once it has reached the 100 degrees Celsius, after that we can apply the formula for latent heat of water. Okay, so first ms delta T, this much heat will be required for water to go from 20 degrees Celsius to 100 degrees Celsius. Once it has reached to the 100 degrees Celsius, then we will provide the latent heat which is m into L to convert that water from 100 degrees Celsius to steam. Okay, so voltage how much they have given? 200. Its square we have, so 200 into 200. Resistance is basically your 20. Time we want to find, m I am taking common outside the bracket. Specific heat of water they have given 4200. Temperature final we want 100, initial we have 20. This is the change in temperature we have. Mass we have taken outside. Latent heat is basically 2260. After this 1000 we have multiplied, it means 3 more zeros will be there. Now next thing, zeros will get cancelled, this 2 and this 2 also will get cancelled. 200 into 10, it will be basically 2000 times of t. mass is basically your 1 kg. After this 4200, 100 minus 20 will be basically 80 plus 2 2 6 1 2 3 4. Now let's cancel some zeros. 1 2 3 1 2 3. Here also 1 2 and 3. These zeros we have cancelled. Now t will be equals to 8 2s are 16, carry 1, 4 8s are 32, 33, 336 plus 2260 divided by 2. Let's divide it by 2. 2 1s are 2, 2 6 are 12, 2 8s are basically we have 16, 2 1s are 2, 2 1s are 2, 2 3s are 6 and again 0. So time value will be 8 9 2 1, that is 1298 seconds, but they have given the answer in minutes, so we will have to divide this value by the 60. So 1298 divided by 60, it will be 6 2s are 12, 6 1s are 6, 6 6 are basically 36, again 6 3s are basically we have 18, and in divide basically here we will be having decimal 216 point, again it will be basically 6 we have, oh forget about it, just up to 3 decimal I will take, divide by I have 10, so it will be basically 21.6 minute, and the option which is closer to 21.6 minute is basically we have 22 minute, which will be our final answer. Okay.